Hi everyone. My name is Pavan, and if you have seen my previous videos, by now you would know that I'm trying to record some videos of questions that I think do get asked during front-end interviews. Um, so today I'm going to switch from React to plain JavaScript. I'm going to go over implementing clearAllTimeout. Before going into implementation of this, what's the use and when do we use this? So especially for building libraries like React and uh, Angular and others, they usually have state changes and page transitions. Now let's take an example of routing. When you are transitioning from route A to route B, you might have set a lot of set timeouts as part of the route A. And just when you are transitioning from route A to route B, you don't want to execute any of the timeouts which might execute after you have transitioned to the route B. So there should be a way where you can just go and cancel all timeouts that have been set previously, which is what we will try doing over here. So the goal is to implement clear all timeout. And this should handle clearing any timeout which has not finished executing yet as part of the callback queue, and cancel all of it, so that when you move to the next transition phase, you don't have any asynchronous activity from the callback queue getting executed. There are various ways of doing this. I'll go over two approaches, which I think are pretty easy and simple to understand. So the first one I'm going to do using closures, and I'll discuss the reason why I'm doing that. So one of the things that you need to understand over here in JavaScript, everything is prototype based, which implies that you can go and override any of the functions if you're able to access the prototype chain and override it, so that you can go and change the function signature and do something different using that, which is what we are going to do over here. Uh, so now what I'm doing, I'm going to change a little bit of implementation over here. I'm not going to use a function clear all timeout. I'm actually going to bound it to window namespace, which is what even a function clear all timeout is going to do over here. So let's create an iffy, which is an immediately invoke function. And I'm going to use this to create a closure. And I'm going to say clear all timeout, which is what we have over here, and attach it to window. And let's give it a function, which we will define as we keep doing this code. Now let's go and temporarily, let's store the existing window clear timeout, window.set timeout and window clear timeout into a temporary variable. So temp clear timeout is equals to window.clear timeout. We'll do the same thing for set timeout. Cool. I'll tell why I'm doing this. The reason is because I'm going to override that function now, so that I can get access to the variable that I would define in the closure and be able to push into the array. So let's have a array over here created for instances. So this is acting as a private variable, uh, and it's only going to be accessible in this closure. No window.set timeout outside of this would be able to access this variable from anywhere. And now, before we get into implementing clear all timeout, let's override the existing window.set timeout. Now, what's usually the third one is context. And what we're going to do is we are going to now execute the existing temporary timeout that we stored as a temporary variable, which is to ensure that the actual timeout function is called. So we are going to do set timeout, and we are going to pass it all the three parameters. What does a set timeout return? It gives you the instance ID. So get the instance ID now over here and return the instance ID. So the function as of now is doing what set timeout is supposed to do, which is going and calling the temporary set timeout and just return the instance ID. But now because I have a hook over here, I'm going to push the instance ID into instances. So because of me overriding this function and using a closure, now I've got a hook where I can store all the instances for all the set timeouts that will happen and store it into the instances array, which I've defined on the top. I'll do the same thing for even the clear timeout. So now what we'll do is what is usually an value that we pass to clear timeout. Sorry, let's include clear timeout. So is usually an ID, which is the instance ID. So we're going to pass the instance ID. And now, similar to what we did over here, so let's execute the temp clear timeout and pass it the instance ID. And just return the return value of this function, which in this case is nothing, but just to be sure that we are returning the value back, we are going to take the return of it and then send it as part of the return of the new function that we have created, or the overridden function. But unlike what we did over here, which is push, now we'll remove it from the array. So I'm going to go with splice, which is mutation of an array. Not the most performant approach, but this works for now, which is an O of n complexity. So we're going to do splice. First, let's get the index, which is index of instance ID, which is going to be instances index of instance ID. And we are going to do a splice over here, which is the index and 1. What we can ensure is that we don't do the splice if it is -1. That means that there's nothing in the instances array, then we don't go and land up doing a splice unnecessarily. So we have now executed two things. We have applied the clear timeout, and we have also overridden the set timeout and pushed it into array. But now there's a catch over here, that what will happen in case if the callback function, which is part of the set timeout, gets executed. Nothing is going and clearing our instances array, which means that our instances array will keep growing. And even if a function or a callback is executed within the delay, there's no one releasing it. So how do we fix that? Now we are going to override the callback. So instead of calling the callback, let's call our own function over here, take the arguments, and let's call the callback using apply. So there are two main ways of doing invocation of a function in JavaScript. One is call and apply. The difference between call and apply is how you pass the parameters. So in case of apply, the first parameter is the context to which the function would be bound, which in this case can be context or this, right? And we have taken args. With the spread operator, what we get as part of args is array. So we're just going to pass this as an array. If this was not ES6 and if it was ES5, the way you would do that is you would get arguments from the function, and you would need to cast it to an array using array.prototype .slice .call of arguments, which will cast it to an array. And then you could do this logic that I did over here, but that was if it was an ES5. Thankfully, now with ES6, you can use the spread operator, which does this behind the scenes, and it converts that into an array for you. Remember, arguments is an array-like structure, but not an array. which is why you cannot apply some of the array methods to it. So now what we have done is we have overwritten the callback, and then now we are calling the callback. But now, similar to what we were doing as part of the clear timeout, we are going to get the instance ID index, and if it's -1, we are going to remove it from the instances. What this will do is it'll go and release the function. It'll go and release the instance from the instances as soon as the callback is executed. So now we are going to keep emptying or reducing the item from the instances as and when the callback finishes. Cool. So we have implemented now clear timeout and set timeout. Now what do we do with clear all timeout? Now this is very straightforward. All you're going to do is you're going to iterate through instances. And you're going to just go and call the window.clearTimeout with the instance. Just ensure that you don't call the window.clearTimeout, because it's actually going to result in a splice again, which is going to be having some complications. To avoid that, you don't call the window.clearTimeout, you actually call the temp clear timeout. This way, you don't execute any of this code. And now you can just go and empty the instances array over here. So we'll do an let, because we are going to update it over here and empty it. Sorry, we have to empty it after the loop. Cool. Now let's try running this and see if all the test cases pass. Awesome. So we have got all the test cases pass. As I said, I'm going to do this with 2 approaches. Now let's go with the second approach. The second approach is pretty awesome. You'll be surprised. I would say it's a hack, and sometimes it's not going to work all the way you would expect, but it's a pretty brilliant solution, which I read. So the thing about set timeout is that the way it works behind the scenes is JavaScript increments the index. So it's always going to be an incremental index. So let's say you have created a set timeout, the value of it could be 1. And the next time when you create another set timeout, the value of it is going to be 2. And so on and so forth, where it'll keep incrementing every time a set timeout is called. So we'll take that, and then we will use that to our benefit to clear all timeouts. So let's take the current instance. Let's create a set timeout with a 0 timer with a callback. So I'm creating a new set timeout, and I'm going to take the value inside it, take the instance value of it, and do a 0 delay. Now what I'm going to do is I'm going to iterate through and let's also make this let, because we are going to mutate this. I'm going to now have a while loop, which will run till my current instance doesn't become 0 or null or undefined. And what I'm going to do is every time I'm going to decrement the value of it. But while I'm doing this, I'm going to do a clear timeout, and I'm going to release the timeout that was currently running. So what I'll get, and that's it. I mean, that's the code. So this just, and you can, in fact, if you want, you can make this a little better, and you can do minus and reduce one more line of code. All you're doing is you are creating another set timeout, taking the current instance and decrementing the value. And before decrementing the value, you're going to clear the timeout for it each time. So that when it comes to 0 or -1, finally, you are going to ensure that all the timeouts before it have been completely removed and are no longer going to execute. Let's try this out and see if this works. Awesome. Cool. So that's it for this video. Two approaches. If I were to do this in an interview, I would do this as my second solution, and this would be my primary solution. This gives the interviewer a good understanding that you know how to override functions in JavaScript. How do you ensure that you are able to hook onto it and then store the instances and then release it? It also helps with understanding that you need to even know that you have to go and override the callbacks to release the value from the instance. And you can simplify your code by iterating and calling clear all timeout. And instead of doing a splice every time by mutating the array, you just release everything from the array in a single go at the end, which is an operation right after you've done the iteration. Cool. Thank you, folks. I'll stop the recording.